Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions for today's session. Okay, so the first question just simply asks, how do you convert grams to moles and moles to grams? Basically, if we know that the number of moles is equal to mass over molar mass, I'll also add in their units as well. So obviously number of moles is in moles, mass is in grams, and molar mass is the value that you would find on your periodic table, and it's different for every element, and its unit is in grams per mole. So in a question, you're usually given either 2 and you're asked to solve for another. Either way, you would just use this main equation, rearrange it to end up solving for your unknown. So let's see the answer from our junior tutor. It looks like they have an example. For instance, if you want to convert 20 grams of water to moles of water, it is the same as finding the number of moles in 20 grams of water. Use the appropriate conversion factors to eliminate the given unit and bring about the desired unit. So they have 20 grams of water, and then you divide it by the molar mass of water, which is 18.08 grams per mole. And they ended up calculating it to be 1.109 moles of water. To convert from moles to grams, use the same process. So they reversed it. So they said converting 1.5 moles of water to grams, you need to multiply by the molar mass, and you end up getting 27.03 grams of water. So we can say that this solution is correct. Okay, so question number 2 asks, how can I calculate specific heat capacity of water? So I'm just going to write down the formula. Q is equal to mc delta T. So Q is just the heat that is usually like released or required. M is the mass of the sample. And the variable C represents the specific heat of the material. And lastly, delta T is the change in temperature. So sometimes a question will give you 2 temperatures, the initial temperature and the final temperature. But to calculate for delta T, it's going to be the final temperature minus your initial temperature. Okay, so let's see what the junior tutor said. Specific heat, C, is the amount of energy or heat needed to raise the temperature of a quantity of sample, moles or mass, by 1 degree. The working equation involving solving the heat required to raise the temperature of the material is Q equals mc delta T. Q is heat, m is the mass of the sample, C is the specific heat of the material, and delta T is T final minus T initial. If we want to solve the specific heat of water, derive the equation given above to solve for the value of specific heat. Okay, so in the question they might give you the Q and the mass and the delta T, and then you just plug it into the equation to solve for the specific heat of water. So this solution is correct. Okay, so question number 3 asks, how do you convert teaspoons to grams? Okay, so first let's recall that 1 teaspoon is the same as 5 mils. And 1 milliliter is equal to 1 gram. So that's that. So basically, yeah, you would use these conversion factors. So let's see what the junior tutor said. Conversion factors are useful tools when converting one unit to another unit. What we currently have to convert teaspoons to grams are the conversion factors. 1 teaspoon is equal to 5 mils, and 1 mil is equal to 1 gram. If you have 5 mils of sample, which is equal to 1 teaspoon, this measurement is also equal to grams via 5 mils times 1 over 1 converts it to 5 grams. This means that in 1 teaspoon you have 5 grams of the sample. Thus, the conversion factor of a teaspoon to grams can be established as 1 teaspoon is equal to 5 grams. For example, if you have 3 teaspoons, this measurement can be converted in terms of grams using the conversion factor above. The conversion will be as follows: 3 teaspoons times 5 grams over 1 teaspoon is equal to 15 grams. The result means that you have 15 grams of the sample on 3 teaspoons. So this solution is correct. They also had a good example. Okay, so question number 4 just asks, what is an ion and how is it different from an atom? So an ion, let me just write out a table. I don't even think it needs to be that big. But an ion is when the species is charged. So it can either have a negative charge or it can have a positive charge. So I'll also write down an example. Let's say you had sodium plus, which means it lost an electron. So this is an example of an ion. Or you can have Cl minus, which means it gained an electron. Okay, so then as you can guess, an atom is just when you have your neutral element, so there's no charged, and it has an equal number of protons and electrons. So for example, it would just be like sodium without the charge, and like chlorine without the charge as well. The sodium, yeah, let me just see what the junior tutor said. An atom is either neutral or charged, which is ion. A neutral atom is composed of equal number of protons and electrons. For example, a natural sodium atom has 11 electrons and 11 protons. If sodium gives up its only valence electron in pursuit of attaining an octet, so it becomes more stable when it has a full octet, then it becomes a charged atom, also known as an ion. It attains a positive charge and its symbol becomes Na+. On the other hand, chlorine has 7 valence electrons. To attain stability, it may accept sodium's valence electrons and thereby becoming a negative ion, such as an anion, with a symbol Cl-. Hence, ions are charged atoms, atoms that have either lost electrons or atoms that have gained electrons. Positive ions are called cations, while negative ones are called anions. This solution is correct. Okay, so let's move on to question number 5. What is an anomeric carbon? Anomeric carbon. Basically, it is the carbon that contains either an aldehyde or a ketone in its acyclic form. So acyclic means that it's linear. Of a carbohydrate. So carbohydrates can either be in a cyclic or an acyclic form. And your anomeric carbon is the one that contains your aldehyde or ketone. So when it is converted to its cyclic form, then the double bonded oxygen is just converted to an alcohol. So let's see what our junior tutor said. Anomeric carbon is the carbon that is in the carbonyl group, so ketone or aldehyde, of a straight chain structure. For example, considering the ring of glucose, the anomeric carbon is located at the chiral center, which is at carbon 1. Okay, so here they labeled where the anomeric carbon would be in its cyclic form. So this solution is correct. Okay, so moving on to question number 6. It just asks, what is the formula for hydrochloric acid? So this is one of the simpler, well-known acids, and basically it just contains hydrogen bonded with a chlorine. I'll just draw in the lone pairs of chlorine. So its chemical formula is simply just HCl. Let's see what our junior tutor said. An acid, Arrhenius acid, is a compound that increases the concentration of H+ ions that are present when added to water. Hydrochloric acid's formula is HCl. It is a gas at room temperature with a boiling point of -85.1 degrees Celsius, but it undergoes complete ionization when dissolved in water. So here they actually show when you have the hydrochloric gas mixed with H2O, it produces H3O plus the chlorine ion, so it is a strong acid. And this solution is correct. Okay, so moving on to question number 7. What is the Diels-Alder reaction? So, the Diels-Alder reaction is basically the conjugate addition reaction of a conjugated diene. So it means it has two double bonds to an alkene or alkyne. So in the end, you typically produce a cyclohexene. So I'm gonna write out the mechanism. So first I'm going to draw out my conjugated diene. So this is one of the simplest ones you could draw. And I'll show it has the two double bonds each, and it has like a single bond in between, so that shows that it's conjugated. And I'll label the carbons 1, 2, 3, and 4. Then I'm going to draw it just reacting with a simple alkene. And for the mechanism, I'll show the movement of electrons using the arrows. Oops. So we'll have this double bond attacking here. Which shows all of the movements of the electrons. And we're left with a cyclohexene product. And it contains a newly formed double bond right there. And if I were to show the carbons again, this is carbon 1, 2, 3, and 4. Yep, that's pretty much to it. So let's see what the junior tutor said. Diels-Alder reaction is a reaction wherein a 6-membered ring is formed from 2 molecules by cycloaddition. Here we have a diene reacts with an alkene, which is our dienophile, to form cyclohexene. See the figure. Take note that the reaction only happens in one step. So let me say that this also takes place when the reactants are heated. In the reaction, the dienophile attacks the first carbon of the diene to form a single bond. Electrons from carbons 3 and 4 will be kicked out to form a single bond, while forming a double bond between carbons 2 and 3. Note that heat is not required for the reaction to proceed, but will result to greater yield. Great, so this solution is correct. Okay, so now let's move on to question number 8. How would you calculate the molar mass of water? Okay, so as we all know, the chemical formula for water is H2O. It contains an oxygen that is bonded to 2 hydrogens. So to calculate the molar mass of water, first I would need to get the molar mass of hydrogen and oxygen, which are found on the periodic table. So the molar mass of hydrogen is simply just 1.01 grams per mole, and the molar mass of oxygen is just 15.99 grams per mole. To calculate the molar mass of water, all we need to do is add up the molar mass of hydrogen plus 2 times the molar mass of oxygen. Oh, sorry, it's the other way around. It will be the molar mass of oxygen times 2 times the molar mass of hydrogen, since there are 2 hydrogens for every 1 water molecule. So now let me just plug these values in. 1.01 grams per mole times 2 plus 15.99 gives us a final molar mass value of around 18.01 grams per mole. Okay, so let's see what our junior tutor said. The molar mass of water refers to the mass of 1 mole of the water molecule. To find it, multiply the individual atomic mass of each of the elements involved by the number of atoms involved indicated by the subscripts, then get the sum. So here they actually show out that the molar mass of hydrogen is 1.0097 times 2, and they only had to multiply the molar mass of oxygen by 1. They added the 2 values together and also got 18.01 grams per mole. So this solution is correct. Okay, so moving on. What is the molar mass of methanol? Okay, so let's first try to answer this question as if we don't know what methanol would look like. So first, let's analyze it. It has a prefix of meth, so that means we know that the parent chain is only composed of 1 carbon. And we can also see that methanol ends in -ol, so we also know that it contains 1 alcohol group. So alcohol functional groups are OH. So now let's write down the structure. We have the 1 carbon. We know it contains an alcohol, only 1 alcohol. But since carbon needs 4 bonds in total to make it stable, I'm going to fill out the rest of the bonds with just hydrogens. So therefore, we can say that methanol has a chemical formula of CH3OH. So I wrote it like this just so that we can see that it contains an alcohol group. So when we want to calculate its molar mass, first I'm just going to write down the molar mass of carbon, hydrogen, and oxygen, since these are the atoms that are involved in methanol. So you would just find these values on the periodic table. The molar mass of carbon is 12.01 grams per mole. The molar mass of hydrogen is only 1.01 grams per mole. And finally, the molar mass of oxygen is around 15.99 grams per mole. So, to write down the molar mass of methanol, we need to take into account how many atoms of each element are present in the compound. So there is only 1 atom of carbon. So I'm going to do the molar mass of carbon plus 4 times the molar mass of hydrogen, since there are 4 hydrogen atoms. And again, there's only 1 oxygen atom, so it's just going to be the molar mass of oxygen. And then I'm going to sub in all my values. So 12.01 grams per mole plus 4 times 1.01 grams per mole plus 15.99. So we end up getting a final molar mass of ethanol to be 32.04 grams per mole. Okay, so let's see what the junior tutor said. Methanol is a naturally occurring alcohol that is found in woods, hence its name, woody alcohol. It can also be found in volcanic gases, fuels, and even fruits and vegetables have little traces of it. It is a simple alcohol containing a methyl group, CH3, that is bonded to alcohol, OH. The chemical formula of methanol is CH3OH. It is a colorless liquid with a distinct odor. It has a molar mass of 32.04 grams per mole, boiling point of 64.6 degrees Celsius, and it has a density of 792 kilograms per meter cubed. Okay, so this solution is correct. They also gave some informative background on what methanol is. Okay, so moving on to question number 10, I believe. How many grams of glucose would you use to make a 2 mole per liter solution in 1 liter? The molar mass of glucose is 180 grams per mole. Okay, so first I am going to write down everything that is given in the equation. So they gave us the concentration of the glucose solution, which is 2 moles per liter. they gave us the volume of that solution, which is 1 liter, and they also gave us the molar mass of glucose, which is 180 grams per mole. And we are looking for the mass. So this is a 2-step question. And the first thing we need to do is find the number of moles in the solution. Step 1, find number of moles, also known as N. Okay, so to find the number of moles, first they gave us concentration and volume. So we know that concentration is equal to the number of moles divided by volume. So I am going to rearrange this equation so that we're solving for number of moles. So it's just going to be concentration times volume. So we know the concentration is 2 moles per liter. We know the volume is 1 liter. So if we multiply the two together, you should see the liters canceling out, and we're left with the value in moles, and all it is just 2 moles. So after we find the number of moles, now we can find the mass. So step 2 is simply just find the mass of glucose. And we can do this using the equation number of moles is equal to mass over molar mass. So again, I'm just going to rearrange this equation so that we're solving for mass. And it's simply just the number of moles times the molar mass. So we calculated the number of moles in the previous step to be 2. And the question also gave us the molar mass of glucose, which is 180 grams per mole. So again, if you multiply the two values, you'll notice that our moles will now cancel out, and we are left with a value that is in grams. So therefore, we can answer the question now. There are 360 grams of glucose. And this is used to make the 2 moles per liter solution in 1 liter. Okay, so let's see what our junior tutor said. The molarity is given by M equals number of moles over volume. This can be used to calculate for the number of moles of the solute, which in this case is glucose. Deriving the equation for the number of moles of the solute gives concentration times volume. And they got 2 moles as well. Given the number of moles and the molar mass, the mass can be calculated using the equation M equals N times capital M. Substituting in N equals 2 and molar mass is equal to 180 gives us 360 grams of glucose needed to make 2 mole per liter of 1 liter solution. So this solution is correct. Okay, so question number 11 just asks, how do you calculate the percent yield of the reaction? So I'm just going to write down that percent yield is equal to your actual yield divided by your theoretical yield times 100%. So your actual yield is how much product you actually obtained after performing the synthesis and your theoretical yield is calculated using stoichiometry and when we know how much of the reactant we started with. So I'm just gonna say, and when we know mass of reactants. Okay, so this can also be described as how much product we expect to have. Okay, so let's see what the junior tutor said. In reactions, we can quantify the mass of the product using measuring equipment such as an analytical balance. The mass always deviates from what is the predicted mass, or so-called the theoretical yield, due to some factors during an experiment. The yield of the experiment can be represented in terms of the percent yield, which is the amount of the products produced in the actual experiment compared to the theoretical calculations multiplied by 100%. They give out the same equation that I have. So this gives you an insight into how effective the experiment you conducted was, depending on the mass of the product you produced. So in problem-solving cases, most of the time the actual yield is given, and you want to get the theoretical yields of the experiment. You can simply solve it using stoichiometry. The molar ratio of the reactant to the product will be given. It gives you the number of moles of the product, and you just have to solve for its mass by multiplying the number of moles to the molar mass of the reactant. For example, you want to synthesize magnesium oxide. In your experiment, your yield is 2 grams, and you started off with 5 grams of magnesium metal. What is the percent yield? So the first thing you want to do is write out the chemical equation of the reaction, and it's also important to make sure that everything is balanced. So here they balanced it already. 2 magnesium plus O2 gives 2 magnesium oxide. The molar masses of magnesium and magnesium oxide are 24.3 grams per mole and 40.3 grams per mole, respectively. Next step is to find the number of moles present in the reaction you used. In this case, it is the magnesium. We have the number of moles is equal to 5 divided by 24.3 to get 0.21 moles of magnesium. Okay, so then they can calculate the number of moles of magnesium oxide that is produced. We know the molar ratio is 1:1. Thus, the number of moles of magnesium oxide that must be produced is the same as the number of moles of magnesium. Now for the mass for these corresponding moles is 0.21 times 40.3 gives 8.5 grams. And then finally we can calculate percent yield. So our actual yield, they said was, so it should be the 2 grams divided by how much we expect it to have, which is the 8.5. times 100%, So let me just do this calculation showing that our yield was actually 2 grams divided by 8.5 times 100. So the actual percent yield was 23.53. So I'm just gonna write that their explanation is correct. However, for the example, is equal to 2 grams divided by 8.5 grams times 100, and I got 23.53%. Okay, so the explanation was correct. They just put in the wrong actual yield. It should have been the 2 grams that was given in the question. But I'm still going to say that the solution is correct. Okay, so now let's move on to question number 12. How do you calculate the energy of a photon of electromagnetic radiation? So I'm going to write out the formula. E equals, you write it in the middle. E is equal to hc over lambda. Okay, so as you can guess, E is the energy of photon. H is actually Planck's constant. And its value is 6.626 times 10 to the negative 4, or negative 34 joules times seconds. C is the speed of light. So it is another constant that is simply just 3 times 10 to the 8 meters per second. And finally, lambda is your wavelength. So sometimes it's given in nanometers, but when you want to plug it into this equation, make sure you convert to meters first. Just because the speed of light is given in meters per second, so we just want everything to be in the same units. Okay, so let's see what our junior tutor said. To calculate the energy of a photon, we can use either of these formulas. E equals hf or E equals hc over lambda. H is Planck's constant, 6.626 times 10 to the negative 34. F is frequency in hertz. So I'm going to write down this equation as well, where frequency is simply just, where is I going with this? Yeah, 1 over S. So when you have a frequency value that is in hertz, this unit is the same thing as 1 over S. So it's basically simplifying the equation that we have on the right side. And we can write it as F is equal to C over lambda. So this is another equation as well. It just depends on what values the question gives you. Okay, so moving on, C is the speed of light, 3 times 10 to the 8 meters per second. And the lambda is wavelength of radiation in meters. So this solution is correct. Okay, so question 13 asks, a sample of chlorine gas has a mass of 39.2 grams. How many chlorine gas molecules are there in the sample? So this is a multi-step question. You'll notice they give us the mass of chlorine gas, which is 39.2 grams. What we also need in this question is the molar mass of chlorine gas. So if we look at our periodic table, the molar mass of a single chlorine atom is 35.45 grams per mole. So the molar mass of chlorine gas is simply just 2 times this value, since there are 2 atoms of chlorine. So 2 times 35.45 gives us a molar mass of 70.9 grams per mole. I'm also going to write down a helpful unit, well, constant called Avogadro's number. And Avogadro's number is equal to 6.022 times 10 to the 23, and the units are in molecules per mole. So now I have everything needed to answer the question. And the first step is to first calculate the number of moles of chlorine. So if you don't remember, number of moles can be calculated by performing mass over molar mass. So what was given in the question was 39.2 grams. And we just found the molar mass of chlorine gas to be 70.9 grams per mole. So if we multiply out these two values, you'll notice that our grams will cancel out, and we're left with a value in moles, which is 0.553 moles of chlorine. Okay, so for the second step, for number of molecules, first I'm going to write out the number of moles that we calculated the previous step, which was 0.553 moles. And now I'm going to multiply by Avogadro's number, which is the 6.022 times 10 to the 23 molecules per mole. So you can see that you did it right if our mole should cancel out. And we're left with a value in molecules, which gives us a final answer of 3.33 times 10 to the 23 molecules of chlorine gas. Okay, so let's see what our junior tutor said. To answer the question, we have to review first the concept of Avogadro's number, first coined by Amedeo Avogadro, who explained that the volume of a gas at a given pressure and temperature is proportional to the number of atoms or molecules regardless of type of gas. It relates the molar mass of a compound on an atomic scale to physical mass. It is the number of elementary particles per mole of substance. So what they mean by particles is it can be like molecules or photons. So the mole is represented by Avogadro's number, which is 6.022 times 10 to the 23 units per mole of a substance. So first they found the number of moles of chlorine gas, 0.553 moles, and then they multiplied by Avogadro's number to also get 3.33 times 10 to the 23. So this solution is correct. Okay, so now let's move on to question number 14. What is the name of the following ion H2PO4-? So this is an example of a polyatomic ion. So PO4- is the phosphate ion. And we can see that there are 2 hydrogens. So we would use the prefix di. So therefore we can name this ion as dihydrogen phosphate. Okay, so let's see what our junior tutor said. Using the rules on naming polyatomic ions, the presence of hydrogen and its quantity will depend on how it is named. For the question, the hydrogen content of the polyatomic ion is 2, therefore it is named dihydrogen. The ion PO4- has the highest oxidation state. The naming will have 8 at the end of the ion, thus it is called phosphate. And they also got dihydrogen phosphate, so this solution is correct. Okay, so moving on to question 15. What is the molar mass of oxygen? So I'm assuming they mean the oxygen gas as a diatomic molecule, which is O2. So first I'm just going to write out the molar mass of a single atom of oxygen, which is just found on your periodic table, and it is just 15.99 grams per mole. The molar mass of O2 will be 2 times the molar mass of a single atom of oxygen. So 2 times 15.99 grams per mole gives us around 32 grams per mole for the molar mass of oxygen. So let's see what our junior tutor said. Oxygen exists as a diatomic molecule O2 in the air. From the periodic table of elements, we know that one individual oxygen atom weighs 16 grams per mole. Thus, 2 oxygen atoms will weigh 32 grams per mole. So this solution is correct. Okay, so moving on to question number 16. In the following acid-base equation, H3PO4 plus H2O makes H3O plus H2PO4 minus, which is considered to be a monoprotic acid. So first I'll write down the definition of monoprotic acid. Basically, this is the substance that only donates one proton, which is the same as H+. So similarly, if you had a monoprotic base, this only accepts one proton. So let's see the reaction equation they gave us. You have H3PO4, you have water, which makes H3O plus H2PO4 minus. So if we look at the whole equation, you'll notice that none of these compounds will donate only one proton, since you can see H3PO4 contains 3. Even water has 2 protons, so it doesn't work as a monoprotic acid. And even the conjugate acid is still H2PO4 minus. I mean H3O plus. So therefore, there are no monoprotic acids in the equation. So our junior tutor said the same thing. No monoprotic acids are present. A monoprotic acid donates only one proton per molecule to an aqueous solution. From the options given, there is no H3PO4, which is the only one that donates a proton. However, in many cases, phosphoric acid can give up 3 hydrogen atoms, which makes it a triprotic acid. So this solution is correct. And I think we have time for one more question for this session. So how do you calculate for the molar mass of a substance? So I'm just going to write down that the molar mass is equal to the sum of all your atomic masses with respect to how many atoms there are in that compound. So that's what I just wrote N there for. So let's say for glucose, which is C6H12O6, its molar mass is equal to 6 times the molar mass of carbon plus 12 times the molar mass of hydrogen plus 6 times the molar mass of oxygen. So molar masses of the single elements can be found on the periodic table. And then if we sum up all of these values together, you get a final molar mass of glucose, which is 180.16 grams per mole. So Let's see the answer from our junior tutor. Molar mass is the mass of a substance in grams per amount in moles of a substance. For monoatomic elements, the molar mass is the atomic mass of the element. So the molar mass of helium would be 4.0026. On the other hand, the molar mass of a compound is the sum of all the atomic masses of the elements that made up the element. To illustrate, we can calculate for the molar mass of water, H2O, by adding up all the masses. Okay, so they did the same thing, showing that it's going to be 2 times the molar mass of hydrogen plus molar mass of oxygen gives us 18.016 grams per mole. So this solution is correct. Okay, so I think that is all the time that we have for today's session. And if you like today's video and you'd like to be notified of when we do this next, please hit the subscribe button and the notification bell below. If you'd like to submit a question of your own, then check out the links in the description. Also, if you like today's video, don't forget to leave it a like and a comment. And also share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.